While I do have some nicely pre-shaped 22 gauge wires seen above, for purposes of this demo I actually think jumper wires are a bit easier to understand. And sometimes, who knows, jumper wires can look pretty. So there we go. Powered by 5 volts from my Arduino, we have the rails jumping across to the vertical bus here, and here is a bunch of stuff, including a 1 mega ohm potentiometer. This clock circuit is powered by the most popular IC of all time, the 555 timer. The signal is understandably a bit slow because I've popped in a 10 microfarad electrolytic capacitor. If I really wanted to move things briskly along, I guess I could replace it with this 2.2 cap or smaller, but as we'll see in a minute, I do not. So you might be asking, well, why build such a circuit in the first place? And I suppose the iPhone that you're inevitably watching this on performs binary calculations at a rate determined by a clock that's similar in principle to this one. The difference is that this clock is slowed down to just fractions of a cycle, or hertz per second, while your phone is whizzing along performing billions of calculations per second because it has more than 3 billion transistors packed into it. So that's just a thought to sit on while we enjoy this delightful white light. Now, of course, the light is just an indicator to show that the darn thing is working properly. When you're working on kind of a cheapo breadboard like this, sometimes it doesn't. So the actual output I've drawn out here along this orange line to these 2 green alligator clips, and those form the 2 inputs, or 2 respective inputs to 2 AND gates, triple input AND gates at that. So the clock circuit is one of the 3, the other 2 coming in the form of the J and K respectively, or set reset in these 2 buttons. And of course the third input would be a second layer of feedback. So in an older video we saw the SR latch, which is nicely on the perf board here. In SR latch you have 1 layer of feedback just from either one of the NOR gates. But in a JK flip-flop, in addition to that layer of feedback, you also have the result of the NOR gates being fed right back into the triple input AND gates at the beginning, the J and K respectively. And as you can see, the CLK stands for clock, our friend here. But just that one added layer of complexity certainly makes for a bigger footprint, but added an additional 5 hours of construction and debugging time. So while I am happy with the results, I have to say it was significantly more difficult to get this thing to work. Luckily I had the foresight to use sockets this time. I certainly didn't with the SR latch, and consider myself lucky that it works. So anyway, one of the most important differences between a JK latch and an SR latch, or sorry, a JK flip-flop and an SR latch, is that it requires the clock circuit, seeing as we're working with AND gates, not NAND gates, but also that you can actually enter both JK inputs at the same time. It will simply toggle. Those who are familiar with SR latches know that dual simultaneous inputs are impossible in an SR latch, but here they're possible in principle. So it's a bit slow, but that's because the clock signal is slow. There we go. That time it actually didn't toggle. And it's still not toggling. There we go. So there we have it, the clock circuit.